So yesterday, what we did was the concept was we combined three disks, and then let me see if I could do this better here today. Okay, so what we did yesterday was we took three disks, right? One, one, this two, and this three. So this is what we took yesterday. Okay, and all of them were how much? Their size was 8 GB. Oh man, how do I do this? Well, okay. So so yesterday we had three disks, and then we created these are 8 GB each. Okay, 8, 8. So we combined all three. We combined all three and made it a 24 GB. Okay, 24 GB. So let's take a look here. So df-h. No, to find out what the size of the disk are, you type lv scan for the logical value. Lv scan. Okay. Now, not that one. VG display. So over here we have the disk size. We combined three disks and we made it a volume disk, and it's the size of 24 GB right here. And the name of the disk is ZMPT1. You could name it whatever you want when you go through this process here. Okay. So out of that, then what we did was, this is a raw disk. What we did was we created another disk which is about 12 GB, and another 12 GB is left there. So you could see one physical drive, we used three physical drives and make a one big chunk of a disk which is 12 GB. Okay. All right, let's continue on. So what we did, we made a disk out of there, right? So df-h, and we mounted um, that to a folder named Chris. Okay, do you see a folder named Chris here? And then you could, these folders you have learned so far, you could mount it to any other disk except this root disk. SDA is a root disk like this one, and is mounted to slash. So let's create some data in here. Touch F So we got 1,000 files in here, right? And then we get out of here and you mount -a or just quiz. Okay, it's gone. Quiz is gone, but the data is still there. Okay, so mount -a and then df-h, and the file is there, and the data should be there too. There you go. Okay, so what we did was we created. So what we could do is we could create another file name, another data disk name, Oracle data. Okay. So we used ZMPT01 and we created a volume name. Actually, you call this as a volume name. They test data. So let's see here if we create a test data here. No, clear this. Get out of here and then type LV scan. Okay, the first chunk we created was 12 GB and we named it data test. Okay, like this. So we're going to create another one and then we call it data_oracle. Okay, so we follow the same procedure right here. You're following the same procedure here. So you type LV create and then -n is for new, and then you give the name data_oracle. Okay, then capital L, that means it's a logical disk. And what size you want to give? You want to give about 4 GB. And what is the volume group name you're gonna cut this out of? ZMPT1. Okay, and hit enter. If I know my English better. You guys could hear me back good, right? There is no echo, anything like that?
No, it's good.
Okay, great. Okay. So, okay, let's see here if what we did is there, LV scan. Okay, do you see this? We didn't have this before here, we didn't have it here. Now we do. This is like another fresh disk now. So what we're gonna do is, it's not usable yet. So you have to follow the other steps to make it usable. So this command is formatting like any other disk. So you use the same command. Okay. So you type the command mkfs.ext4, then you type dev/zmpt right here. You're just copying this information here. Okay. And then hit enter. So this time it worked. It went through the process and it formatted the disk and it's ready to be used now. So let's do LV scan again. Okay, so it doesn't say here. Let's compare it if it has changed anything here. Okay, it didn't change anything here. But what you could do is you could do a VG scan. Uh, what was it? LV scan, okay. Not LV scan or VGS. Okay, here's this command here. When you type VGS, it gives you the size of the volume ZMPT, and it's telling you the total size is this much, 24 GB, and then 8 GB is free. Why is 8 GB free? Because we use 12 GB for this drive data test and 4 GB for this drive Oracle. Okay, so now apparently it's so we used how much? 8, 12 plus 4 is how much? 16, right? 16 GB is used and another 8 GB is left here. Okay, yeah, it makes sense. So now this disk is ready to be mounted. Which is ready to be mounted? This disk. We just created that one. So let's see here. We have one folder here named Bashar, right? Right now it's not mounted to anything. Let's see if it's mounted to anything. Cat etc fstab. Okay, so Bashar 1 is mounted to this drive here, but this drive doesn't exist. So how are we going to mount this? We're going to have to edit this. Okay, fstab vi/etc/fstab. Okay, and you go down here and then you delete this and then you do Control V. Okay, so dev /zmpt1/data underscore. How do I remember this? Because it's over here. I almost copied this part and then data test and data oracle. Okay, so I save and exit :X, I save and exit and I do df-h, still not there. What do I do to bring it in here? Mount -a df-h. Okay, so let's see here. Okay, it's not doing it. It says dev/zmpt1/data oracle doesn't exist. So why it doesn't exist? So we have to do VGS. No, not VGS. LV scan. So you have to see if it's matching up. Dev zmpt1/data oracle. It looks good to me. Okay.
Yeah. There's a typo I wanted to say, but I didn't want to interrupt you. There's a typo in the original file. Instead of Oracle, it's ORCALE. I think that's why it's not being brought up or found.
This one?
The original one you made, it was ORCALE instead of ORACLE.
Okay, this is the original one I made. OR. Oh yeah, you're right. So we just copy this, okay? We copy this, and then we go back in here. That one? I forgot, man. I should have taken a screenshot.
Yeah, originally it was ORCALE, so Orcal instead of Oracle. The original file was created as ORCALE.
Ah. OR. What's the difference?
It should be ORACLE. I didn't want to interrupt you. I wasn't sure if you were gonna like see it, but I didn't want to interrupt you when you were doing it.
No, you did it right, man. ORCALE.
Yeah, that's the original file, but it should be if you're trying to do Oracle, it'll be ORACLE.
Yeah.
Excuse me.
So in original, I made a mistake, so you have to deal with the mistake here. And we didn't get the error here, right? So let's type dffnh, and there you go. Okay. So the folder Bashar, it used to be mounted to /sdvd1. Now it's mounting on here. This doesn't make this folder. It sounds ridiculous here, but if something is hard coded, like application is using a folder named this, so it would be very difficult for them once they develop the application and they hard coded this into the application. And if this gets changed, the application will start crashing. If this gets changed, the way it's written, like if there is a spelling mistake in here, the application will start crashing. So you have to be very careful here a little bit. Okay. All right. So it says here now you could. So when we did edit etcfs tab, what we call it as, we make it at permanent, or we make it consistent. If the system were to restart, it will save these values in there. It will save its values in there, and then it will mount itself. So we did talk about mounting here, right? When does it mount? When we talk about mounting over here in the notes, we talk about okay. So it says the first is a bootloader passes control to second. The kernel detects all the devices, initialize drivers, and mounts the rule file system. So what it's mounting doing is it's making it available, okay, and then into read-only mode and kickstart, then reboot and the system initialization. Okay, so now what it's doing is it's remounting. It remounts these files here. So if it doesn't see anything in the etcfs tab, then nothing will get mounted. Okay. So these files are really critical, and these ones that I'm highlighting here are really critical. You just don't go in there and edit anything, okay? You will learn on the job. You don't have to worry about it now. Okay, so back to our logical volumes. Any questions so far? Okay, so let's go ahead and do this here. Let's do something that makes this disk full. Okay, so let's see here. CD Bashar 1. It's nothing in there. So I'm going to copy this command and run it here. What we are doing here is we are simulating. We are simulating if this disk is full. Okay, so let's go ahead and put this in here and then hit enter. It will create a file which will be about 4 GB size. Okay, let's do df-h. The disk which is named Bashar or mounted to Bashar is full now. So what are we going to do now? So it's a problem, right? If something like this is full, it's a problem. You will get a ticket. Somebody is asking for your help. So somebody will open a ticket with the help desk and they'll scream about it that the disk is full, and they should have known that disk is getting full when it was at 90%. You know what I mean? But they wait until it's 100% and you really have to work on it. Excuse me. So what are you going to do? You're going to use this display here, this command vg display. Okay, so you type vg display and then you don't know which one is it, so you go back here and then you type, okay, Bashar is full, and then this is the name of the disk and this is the name of a ZMPT1 is the name of a volume group. So you come here, you run this command vg display and it will give you all the volume groups, and then you look for ZMPT1 and you come down here and it says VG total size is 24 GB, and then don't worry about this. Allocated means which is being used is about 16 GB. Then you have about another 8 GB free. So you could add another 8 GB to this disk, Bashar. Right now it's only 4 GB. So we're going to add another 8 GB to it. Okay. So let's clear this. Okay. I really want you guys to like practice this a lot, as much as you can, because this is very, very important. You will be doing this every day, day in and day out. And during the interview, the interviewer will ask you these questions 100%. If they don't, I'll be surprised. But I will prepare the questions for you, okay? Don't worry about it. Okay, so how are you going to do that? It's a simple command. You use lv extend. It's very simple. So you can type this command dff-h and then keep this ready so that you have a visual what you're doing here, okay? So what you do is type the command lv extend. Okay, L stands for logical, V stands for volume, and extend means extend, plain English. Hyphen L, capital L means logical. Let's go up here in the box. What does L stands for? Logical. And then what size we're going to give? Plus 4 GB. Okay, we could give up to 4, anywhere from 1 to 4, or 1 megabyte up until 4 gigabytes. Okay, and then we have this open here, so we're just going to copy this and then paste it here so that we don't make a mistake. Okay. Okay, so what you have to do is just hit enter, and it kinda have extended the size of the disk here. But let's do a DFFNH and see if it really has increased here. The size should have, over here, should have uh, double itself. Okay, unfortunately, it's not. So what you have to do is you are missing a command. You have to run this command resize to fs. Resize is just as resize. 2 is that's how it is. And F is file, S is system. FS stands for file system. Okay, and then which file system you want to resize? This one. No. By the way, in putty, if you highlight this like once, it has already copied to your clipboard. Okay, once you're highlighting it, it's copied. All you have to do is right click and it will paste it for you. Okay, you don't even have to do Control V. So just to make sure you're doing the right disk, and the right volume, you just copy and paste it like that and hit enter. Okay, it's going to go through its process and do whatever it want to do. And let's go ahead and do DFFNH. Voila. So you see the size is now 8 gigabytes. Before it was 4 gigabytes. Now it's only 50%. Okay, so when you do DFFNH, you're seeing only 3 or 4 here, right? In reality, you will see about 50 in there. 1 5. I mean 50. 50 in there. 70 in there. 80 in there. So don't be surprised if you see a lot more than that. Okay, because the data is very important for the big corporations, and this is where you come in as a Linux admin and you do your stuff. But storing and doing a backup and all that is done by other admins, which are called storage admins. Most of the time, Linux admin and storage admin, they're not doing both things together. There's a separation of duties. So you do only the Linux part, and the storage team people will do only the storage part. They don't have access to the root. They won't have root access to the host. Can somebody tell me what host means? Bashar? Okay, host means nothing, means is just a server. But you, in day-to-day life as a Linux admin, you will call it as a host. That's a correct name. If you're talking to somebody and then they say you have a problem with something, and then they will ask you, what is the host name? So you type host name and hit enter, and then you will give this, whatever it shows up here, you will give this. We'll work on this a little later here. In reality, I'll show you how the host name looks like. Usually it's about 20 characters long. Okay, so you copy that host name and send it to them, or whoever is helping you, you give them the host name. Okay, and if somebody asks you what problem you're having, which volume, so you do DFFNH, and then you copy this and you give the name to person who is helping you, or person who further need to troubleshoot or take care of the issue. You give the volume name. This is the volume name you're going to give them, and they will understand everything. They'll go in their system and do this command, and they know it's mapped to the folder name Bashar. Okay. Okay. Now it's going to get interesting. Okay, so let's do VG scan. We did VG scan here, and then ZMPT is here. So let's do LV scan. Okay, so we have LV scan. Out of ZMPT, there are 2 disks in there. data test and data oracle. Data test is using 12 GB, and then data oracle is using 8 GB. Okay, then we do LV display, and then you come here and take a look here. Okay, the newly we have a LV display here, Oracle. It gives more information here. It gives the information about each and every uh, logical volume. That's what is called. These are logical volumes. In other sense, these are independent disks, but they're using or sharing the physical disk. Okay, so when you type this command here, LV display, so this is a swap. Swap, I told you yesterday, swap is also a logical volume. So don't worry about this. And this is also the logical volume, the root disk, LV root. This is made by installation. When you first did the installation, it creates this as a volume. So this disk is out of your concern, because this is out of your hand. You're not creating it. Operating system is creating it. But this is something you have created. So you could use this command to come back and see here what it's doing. Okay, so this is the path, this is the short name, and this is the volume group. This is out of volume group is GMPT1. And then UUID, we'll learn about this little later. This is like its serial number, its social security number of the disk. If you have thousands of disks, it may be confusing which disk is it, but it has its own serial number here, and its serial number is attached to this volume group. If you change anything in here, the serial number will be different. And then you see logical volume read write access, so it is readable and writable, and it tells you the creation time. So it has a date stamp when it was created. Status is available. You could come here and see it will give you other status like it's down or corrupted or read only. So right now it's available. That means it's ready to be used and good. Okay, and then other information is most of the time you will be interested only in this information. LV size means logical volume size is 8 gigabytes. Okay, and it has other information here. I'm not interested in it. So let's go and take a look at this one here. What this one and this one has in common is these two disks, data oracle and data test, they both have common in is this one, GMPT1, GMPT1, because this is the parent. This is the main block, and these two are cut out of the main block. This block is 24 GB. Out of 24 GB, data test is using about 12 GB, and then data oracle is using about 8 GB out of GMPT1. Okay, any questions so far? Okay, so the command to see the size of this here is VG display. So now here is showing only the VG display is showing, it doesn't show like other four in here because it's showing the parent here, and it's telling us that the size is 24 GB, and then allocated size is about 20 GB, and then 4 GB is free. How is that possible? I thought I used up everything, didn't I? Oracle is 8, and then oh, this is 12. 8 and 12 is 20. So that's right. So there is you use this command to get the information about the volume group. So it is telling you accurate information here that 24 GB is there, and out of 24 GB, 20 GB is used up, and another 4 GB is left. Okay, so what we're gonna do next is, I mean, just for me, I'm bored now, so I don't like 24 GB. I want to add another 8 GB in here. Okay, so how are we gonna do that? So what we're doing is we're adding another hard drive to this volume group. Okay, so what you have to do is actually you have to add another physical disk. How are we gonna do that? We don't know that. So let's clear the screen and do cat proc partitions. It has a lot of information in here. So you come here and take a look. SDB, does it have any partition? Yes, it has a partition. How much is the size of SDB? And the size of partition is almost similar. That way you could determine SDB is used up. You come and take a look at SDC. It's about 8 gigabytes. And does it have a partition? Yes, it does. And how much is it using? Almost everything. Okay, you skip that. So D is also used up. You come to SDE. Okay, SD is there, but is there a partition to it? No. I don't see SDE1 or 2, anything like that. And SDEF. So we have 2 more disks sitting and not being used up. So what we're going to do is we're going to exploit it. So let me show you what those disks are. Yesterday I showed them we used this one, this one, this one. These 2 are sitting around and getting wasted here. SDE and SDF. This is probably SDE and SDF. I couldn't tell you for sure, but I'm taking a wild guess because what is showing in here is not what the Linux is looking at. Okay, so but we'll just determine these 2 are E and F. Okay. All right. So what we do is we remember I did fdisk to create the partition and all that. This time around I'm not going to do fdisk command. I'm going to go directly. I'm going to type pv create sdd. Okay, so which is sdd is already used, so I'm going to type pv create sde. P is physical, v is volume, create create, and then I'm going to use sde /dev/sde. Last time I used the process of doing fdisk, right? I used the process of creating fdisk. So to avoid that, what I'm using now is I'm just directly, without any concern for anything, I'm just using this here, extending the volume. Okay, so let me go ahead and go back and show you if you have forgotten. I typed fdisk, and then I have to go in here, and I go in here, then go print the partition, then I'll partition, and then the new partition, and I created a primary, and then I created one, and then I defaulted, and I'm going to use all 8 gigs, and then I push P, and I created this partition as SDE1. This time around I'm not going to do it. Okay, I'm going to quit it. So quit without saving changes. So I'm avoiding all these steps here. I'm avoiding the confusion. Okay, so let's clear this out, and let's confirm that the SDE is still available. And SDE, nothing has changed. Even though we went and tried to make a partition, nothing has changed because we backed out of it. We didn't save the changes. So let's go ahead and create this. Let me get out of here and type for pv create pvcreate. Okay, P stands for physical, V stands for volume, create, CREATE. Okay, and then what we're going to create, dev slash SDE. This is the disk, SDE, and hit enter. So it created a physical volume successfully. Now, what I'm going to do is I'm going to add SDE to ZMPT1. Okay, so VG display. Okay, ZMPT1, and it says here it has this one LV2, and I thought it said it has 3 drives. Okay, what does CUR means? Current. PV means physical volumes. It has 3 in it, and actual physical volumes 3. So these two are matching. Okay, maximum it doesn't have. So I don't know what data is, but we're not worried about that much. Okay, and then let's see here. What does 3 means? Okay, I'm not worried about that here. So we're going to come back here and see if these numbers are going to change. These numbers will tell you how many physical. Most of the time we are worried about this one here. Current physical volume 3. So it should change to 4. So we're going to run the command. What we're running, VG extend. So this is a volume group. VG display means this is volume group. Volume group name is ZMPT1. So we're going to use the command VG extend and then ZMPT1, and then we're adding this drive to it. Okay, so let's check it out. The command is V volume G for group extend, and then which volume group you want to extend, ZMPT1. And then how do you want to extend it? We are adding it another physical drive to it, dev slash SDE. Okay, and hit enter. It says successfully extended. So now there is 24 GB here. When I run this command VG display, this should add more to another 8 GB. That is going to be 32. This is going to be go up to 12, and 20 is going to be used up. So with the command VG display. Okay, let's take a look here. There you go, confirmed. It's about 32 GB, and it's using 20 GB because we have other 2 drives, 12 and 4, and the free is about another 12 GB. And then the current size of physical volumes is 4. It has 4 physical drives in it. Which ones? It's using the full physical 1, 2, 3, 4. It's using all these 4 in here. Okay. Okay, so I see there is another command here, PVS. Let's see what it does. PVS. Aha. Now you could see clearly here that which drive is being used by which volume. Previously we couldn't tell. It just has ZMPT1. It has just 4 drives in it. Okay, and then it just had a size. But PVS is physical volume scan. That's what it stands for. Let's see PV scan. What is? Okay, almost it's giving us the same information and a little bit extra information here with PV scan and PVS. Okay, when we're looking at the ZMPT1, we see it 4 times here because there are 4 physical drives it's using: SDB1, SDBC, SDBD, SDBE. We don't see SDBE1 because we didn't make the partition, we just added directly to it. Okay, and then we ran the PV scan, so it's only this information is extra, I suppose. And it's telling you, it's kind of explicitly telling you how much is free or not. 8 GB is 0 free. I don't know why. SDBC, out of that, oh yeah, 3 GB is not being used. And we just added SDE. So the 8 GB and 4 GB is free. Which confirms here that 8 GB and 4 GB makes 12 GB. This is 12 GB, okay? Okay, let's see. It has another display, VGS display. I think it's just VG display. Yeah, it's the same one we already talked about, VG's display. So I explained you in this here. It's just explaining you what it was using 3 disks. Now I showed you using 4 disk here. Okay, so what happens was if the disk is failed in here in the volume group, it happens, right? It's a physical disk. It could fail anytime, right? So what you have to do is you have to, once you find out the disk is fail, you have to add another disk and then remove the failed disk. Okay, so let's see here. We're going to add another disk here. Okay, so we have another disk here, SDF, which is not being used here. So we're going to add SDF to the volume group ZMPT1. Okay, so we're going to use VG extend. We're going to use this. We're going to use this command here. So pv create okay, and then VG extend. Then do VG display. So here we added another 8 GB. So it's on to 40 GB, okay? And all of a sudden, PVF. Okay, all of a sudden, this disk has failed. Which disk has failed? This one, Bashar. It has some data on it. Okay, it has failed. Okay, the disk containing the original disk, we added SD B and C. One of the C has failed, right? Which one is being used a lot? This one here. Let's fail this disk. Okay, so very risky thing is going on right now. It has data on it, SDB1, but this one here, it has 4 GB of data being used here. So it's being used either from here or any of this here because it's part of a volume group. All right, so how are we going to do this? Okay, we are done with that here. So we have a failed drive. So we added, it's telling us on the number 4, line number 4, it says add a new physical disk. We just did it a moment ago. And then add a volume group. So we did a VG extend already. Now there are 4 disks in the volume. Check the data in one of the logical volume. So All right, let's go in here in Bashar. Okay, so in Bashar, there is a file about 4 giga, one big old file which is about the size of 4 gigs. Okay, we can't afford to lose that. And then Chris, and we have about 1,000 files in here. So we have about 1,000 files in here. We can't afford to lose that. Okay, all these 2 drives are part of these 2 drives are part of a volume group which is SD, which is ZMPT1. Okay, ZMPT1. All of them are coming in from here. So PG scan, PVS. Okay, LVS. Okay, so I use this command. I was using LV scan, right? Okay, LVS and LV scan gives out almost identical information, but it has like it's breaking this up here. But most of the time I use LV scan because it's a quick and dirty way to check on it. So out of 40 GB, which we have like 4 disks in it, only two are being used here on ZMPT1. Oh, I think ZMPT1 has 5 disks in it, right? Let's take a look. Yeah, 5 disks. Because we added the 5th disk, now we're going to fail 1 disk. Okay, so we confirm the data is there, right? Now the disk in div SDB1 is failing. So, okay, hold on. Why is it saying PWD test? Now the disk in dev SDB1 is failing. Okay, so what it's saying here is cat proc partitions. So what we're going to do is we're going to remove this disk here, but we don't know the disk, we don't know the data which disk is exactly it's using, because if you remember this disk data test, it is using 12 GB of disk space, but in actuality the size of one disk is only 8 GB. So you could tell the data on this disk is span out. It's spanned across 2 disks. You could just tell it to yourself that the data has spread out, but you don't know what the data has spread out, and you don't know what it is, but you don't have to worry about it. What you're going to have to do is just do this command, and then it will, whatever data it has spanned on SDB, is going to move it to the disk you want on SDE. Okay, so it's a simple command. So how are you going to do that? You're going to use the command pvmove. Pvmove. When we're going to use the physical volume, PV means physical volume, move means move. So it's going to use any data that's on dev SD. In this case, we're going to use B. Okay, then we're going to move it to dev SDE. Okay, but we don't know what data it's holding up because as I said earlier, it's being test in this example, data test is being carved out of 2 disks, but we don't have to worry about it. The system will take care of whatever data is sitting on those disks, and it will move it to SDE. Okay, so let's hit enter. Okay, it says failed to find a device for physical volume as dev SDB. So we're going to use SDB1. Okay, this is a perfect example. When you were using this and moving the data, they would have like terabytes of data. Terabytes of data. It could take 10, 15 days all this to happen here. So you kind of have to plan this activity. When you plan this activity, there is something called change management. So you have to create a CR. What is it? What does CR means? Change request. And you as an admin are not gonna take a unilateral decision that, oh, the data is getting corrupted or the disk is getting corrupted, I'm gonna go ahead and move this data around. You're not gonna do that because you won't be able to do it because everybody in the chain, everybody who's using the system, they will all have to know what is going on. Okay, so whatever data it had on this disk is now being used up here, but we don't know what data is there, right? So if we go here, cd bashar word1 ls, data is still there, and then you go to Chris and data is still there. Okay, then what we're going to do is, so data move complete and remove the faulty disk. So we determine faulty disk being SDB. What disk we move the data out of? Okay, we SDB1. Okay, so let's go ahead and remove the disk SDB1. So what you're going to do is type the command VG. VG stands for volume group reduce, REDUCE. So let's go ahead and do display first. Okay, we are reducing this drive. We are taking one drive out, a defective one, which is SDB1, and then it's about 40 GB. So when we come back here, it's going to be 8 GB less. It's going to be 32 GB. Okay, so we're going to run the command VG reduce. Okay, and what we're going to reduce, we're going to give the name ZMPT1. Okay, so I'm going to remove this drive here. Okay, so what I'm going to do is use the command volume group reduce, and then what is the name of a volume group? I'm going to use the name of volume group ZMPT1, and then if I hit enter, it's not going to work. But you still have to tell the system which disk you want to remove. You want to remove this one, SDB1. Okay, dev/SDB1. Okay, and hit enter. Okay, and it says removed SDB1 from volume group ZMPT1. Okay, so let's type PVS again. PVS. Okay, now you see this this one is there, physical volume is there, but it's not part of ZMPT1. It's it's orphan now. It's on its own. 8 GB is gone. Now you type VG display. Okay, remember how I was telling you is we're going to remove 8 GB because the size of SDB1 was 8 GB. Now it's reduced to 32 GB. And you could confirm we had 5 drives in there. Now it's down to 4. Okay. What about the data? Let's go ahead and take a look. Data is still there, as if nothing happened, because cd/Bashar data is still there. So what it is happening here is Bashar and Chris folders are mounted on these drives, which are logical volumes. These are not physical. These are sitting on physical but being used as logical, but they are spread out. They are spread out. Okay. So that way you could see, like, data is going to be there, or we don't have a chance of data loss because other drives on pick up other drives will pick up if the data is being lost, is because it's being written on all the drives simultaneously, or it may not be writing on all the drives simultaneously, but the data will still be there. So what normally happens is you would be using 4 disks, and there will be a 5th disk attached in here as a standby, and it's being used, but they won't create an extra volume group to it. It will be added in there. So when you get a notification the disk is being filled, you follow these commands, and then you put a new disk in, and then you remove the disk. You go ahead and remove the disk physically, remove it, and then you could go ahead and add the disk here. Let me see if we could remove the disk here physically here. No, we can't. I have to shut it down and remove it. Then I could add more, and that way, you are in a safe side because you're just keeping the data safe. Okay, so everything else from down here are, you could destroy a lot of things here. So let's see. What you could do is most of the time you don't have to do this, but I'm just showing you. I'm going to go ahead and show you for the sake of this course, because once you have created something like this, and normally it will stay there forever until the application is being retired. Most of the time application is there for about 10 years. So you go into the job and then you go start working there, because there will be already some history about all these hosts, and you just follow the run books. You just follow the procedure, and then once you learn the job about in 3-4 months, then you be on your own and following the procedures, and then going about your daily life. But what I'm showing you here is delete logical volume, delete logical groups, physical groups. You don't have to do that. So what I'm going to do is I'm going to U-mount Bashar, then U-mount Okay, I used I I could have used same process for other one, but I just for the sake of demonstration, I used a umount command using to unmount using the folder, and I used the umount command using to unmount using the logical volume. Okay, you have two options. Either you could use it using the folder, or you could use it using the logical volume. Okay, so what we're gonna have to do is LV remove. So we're gonna remove Bashar and test um, from the ZMPT1. VG no LV display LV. Okay, this is much better. Okay, so what I'm going to do is I'm going to remove te data tests from ZMPT1. So when I run LVS again, this won't show up in here. So the command to do it is LV remove. Okay, what does LV stands for? Logical volume. Remove is remove. And it's telling you what you want to remove. Okay, we want to remove this. But you have to give the full path here. So data test. Okay, data test. How much is it? About 12 GB. It says, do you really want to remove the logical volume data underscore test? Yes. Okay, let's do LV scan. LV scan. Okay, it's not there. It's there here, but it's not here. It's gone from here. Okay, so let's do VG display. Okay, well, it says here, and 8 GB is used and 24 GB is back. 24 GB is back because we removed about 12 GB. So 24 and 8, 32. 8, we have 8 disks, we have 4 disks about 8 GB size, so it makes sense. 8 times 4 is 32. Okay, so then what you could do is you could destroy this too. You could take everything out of it. So let's go ahead and do that too. Okay. I'm going to go ahead and remove this also. Okay, let me see if I'm destroying it in the end. Okay, so I'm going to go ahead and remove this too. Okay, now you see the ZMPT, there is nothing in there in ZMPT. It's not even showing up in here. Okay, and then you do LV display. Okay, nothing is there. This is root and this is swap. Now you had all that information is gone. Let's do VG display. Okay, now it has 4 disks in it, and volume group size is 32 GB because of 4 disks, and then allocated is 0 and free is about 32. So we are going in back order. We are destroying a lot of things here. Don't do that at work. You have access to do all this, but don't do it. Okay, and then so we did this. We did this to two of the logical volumes. Now we're going to destroy the logical group, volume group. I'm sorry. So what you do is VG remove. Okay, simple as that. You just type this command and then it's all gone. Too late now. Now it says here, number 3, volume group is destroyed. But it's possible the data is still available on the physical disk. Okay, so let's see here, df-h. Okay, cat /proc what is partitions. Okay, what we could do is we could try to mount SDB1 and see if data is there. Mount /dev/SDB1/Chris. Okay, it says unknown data, so let's see if it mounted. So it has not mounted. Can we do it C? No. Let's just do E because E was part of it. Okay, so it's not doing it. For you to able to recover data, sometimes you may have to take it out of the drive and send it away to the data recovery place. But if the data is spanned across 2 drives, it's not going to be recovered. Okay, so at this moment you have totally destroyed the data, and then if you did it on purpose without any reason or without any CR like change management, you're going to get fired for sure. But here, let's delete the physical volume. Okay, so the command to remove is pv remove. Okay, if you go all the way in the beginning, to remove the physical volume, we did pv, we are going to do pv remove. But what we did was we did pv create. Simple as that. Physical volume create. So we did that. Now we're going to do pv remove command. So we don't know which physical volumes we're going to remove, right? So what you could do is you go back here and you type cat proc partitions, and you have added all these partitions in there, so you could go there and remove it one by one. So what you do is pv remove, then type dev/SDB1. Okay, I'm lazy. Let's try the asterisk, see if it's gonna remove all of them which are in the physical remove. Oh, okay, look at this. With one single command, it went through and tried to remove A. It won't remove A because A is a, what what A is? A is a boot partition. But it went ahead and removed. It did went to C, and it even physically wiped it too. PV, no PV labels found on SDA. So it's not going to mess with that one here. But because SDA was not a part of a physical volume, but SDB, since we already removed it, it's not found in it. No PV label on it. So since we have already removed earlier, it's not going to do it. But it has done it to PVC and D, E, and F. It says successfully wiped. It didn't actually deleted the data. It means it wiped it from the physical volume. So we removed this all the disks from physical volume. Now those disks are independent now. They could be reused if they are not physically or they are not defective. Okay, let's do PVS. It doesn't have much information. PV scan. It just have the information about the existing boot drive. When I say boot drive, it means the drive which is holding a partition table information for Linux operating system. Mm, it's not showing what I want to see. Yeah, I don't know why it's not showing here, but you get the idea. Okay, there it is. Let's take a look here. Physical. Okay, remember when I was doing the FDIS partition, and for SDD we create SDD1, SDD2. So this is what we did here. We created a primary partition, and then we created other. This one is showing extended partitions here, but these are we created another primary partitions here. So this is a full disk, and we create one partition, two, three, four, and then whatever the size allows, it will help you create those partitions here. Okay. Okay, yeah, this is what we basically did here. We had this four drives in here initially, and then volume group is ZMPT1. Out of ZMPT1, we made another volume group named uh, data oracle, and data test, and then it's called file system. We use MK2FS to make it a file system here, right? So data 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 test and data oracle are part of ZMPT1, and ZMPT1 is sitting on top of these drives here. These drives could fail, but this will stay intact. But if all of them fails, then you're in big trouble. So the reason you have this physical drives in here is you keep like one extra in here. That way, the chances of failing all drives simultaneously are very low. And then these drives are monitored, and then if it says disk is going down, then you take an action and change it and add a new disk, and the data which is sitting here and here will still be there. Okay, so let's see here. We are done with this. Should I start another topic here? Or we just have 15 minutes? No, okay. So, all right. Next 15 minutes is going to be open for in discussion. Anybody have anything to talk about? Yakub, you have any questions?
No, I'm good. I did have one originally about the resize, but then as you went through the lesson, I understood. I was wondering if possibly the data was compressed or if it was taken from the other, the other of the three drives. But you got to that, so that was the only question I had, but I answered it myself, so all good.
Your data was spread around. Spread. The data was. Can you mute yourself, please? Yeah, so the data is spread out across the disk. It's called disk panning. So that's where the data was sitting. So, but you would be using. I would say just go in here and practice day in and day out as you're practicing the command. This is going to be really really important. I have all the details from top to bottom here, and I kind of from the start I told you to add three disks here. You could three are minimum for this demonstration. You could play around and have like 10, 15, whatever. Start with three and then start playing around with it. So now that we are like into deep lesson here, so these are really important things here. After the commands, LVMs, you have to memorize this. Memorize in the sense you practice it. The more you practice, the better you're gonna get.